Good morning. So now we will study the addition and subtraction of the vectors. As we know that the vectors possesses both the magnitude as well as direction. Hence, these vectors can be either added or subtracted by using the geometrical methods. For that purpose, we have to represent these vectors geometrically. And once these vectors are represented geometrically, one can either add or subtract these vectors. However, when we deal with such addition and subtraction of the vectors while studying physics, it is very important to remember that whenever we try to add or subtract the vectors, all the vectors that are to be added or subtracted should be of the same kind. So, what does it mean? It means that when we want to add, say, 2 or 3 vectors, all the 2 or 3 vectors must be either of the velocity vectors or of the displacement vectors, or all the vectors must be the force vectors, or they are the momentum vectors, and so on and so forth. So it is not possible for us to add one velocity vector to the displacement vector, or one force vector cannot be added to the momentum vector, and so on. So whenever we want to add the 2 or more vectors, all the vectors to be added should be of the same kind. So this is very important that you must remember while performing the addition and subtraction of the vectors. So here first we shall discuss the addition of the vectors. Addition of the vectors. Let us discuss first addition and then we will go to the subtraction. The different vectors can be added or subtracted by 3 different methods. There are three different ways in which we can perform the addition of the vectors. The first method is the triangle law of vector addition. Second method by which we can perform the addition is the parallelogram law of vector addition. And the third method is the polygon law. So these are the 3 different methods by which we can perform the addition of the vectors. The first 2 methods are particularly used to perform the addition of 2 given vectors, and if the number of vectors to be added is 3 or more, we can make use of this polygon law of vector addition. So let us discuss these 3 different methods of vector addition one by one. So let us first discuss the first method, that is the triangle law of vector addition. If we have the 2 vectors represented in magnitude and direction by the two sides of a triangle taken in the same order. That is, if suppose we have this first vector p bar drawn like this, then the second vector q bar starts from the end point of the first vector p bar and is represented like this. So here what we observe is that the second vector q bar starts from the end point of the first vector p bar, and when we arrange these two vectors in such a way, this is called as the two vectors are arranged in order. And once the two given vectors are arranged in order, then by completing this triangle, that is by drawing a directed line segment from the starting point of the first vector to the end point of the second vector, this vector gives the addition of the two given vectors p bar and q bar. So we can express r bar to be equal to p bar plus q bar. So simply by completing this triangle, when we arrange the vectors p bar and q bar in order, and then completing the triangle by drawing this third side, that gives the sum of the two given vectors p bar and q bar. And this is the triangle law of vector addition. This is the triangle law of vector addition. So here first we have taken the vector p bar and then the vector q bar. Q bar is added to p bar here. Q bar is added to p bar. On the similar lines, if we draw a vector parallel to q bar from the starting point of p bar like this, and from the end, this will be the vector q bar, and from the end point of vector q bar, if we draw a vector parallel to p bar, such that this will be the vector p bar. This will be the vector p bar. So what we observe here is that if the two given vectors p bar and q bar are arranged in such a way that first we have drawn the vector q bar starting from this point, say O. From the end point of vector q bar, if we draw the vector p bar in its magnitude and direction, then here what we observe is that the vectors q bar and p bar are arranged in order, and once the vectors q bar and p bar are arranged in order, then by completing this triangle, by drawing this vector r bar, we can write r bar is equal to q bar plus p bar. So whether we take the addition of p bar plus q bar, or whether we add the vector p bar to q bar or q bar to p bar, in either ways, the resultant we get remains same. So whether we take the addition of p bar and q bar like this or q bar and p bar like this, the resultant of the addition of the two vectors results to be one and the same. So from this, what we observe is that the vector addition obeys the commutative law. So from this, what we can say is that the vector addition obeys the commutative law of vector addition. That is, p bar plus q bar is equal to q bar plus p bar, and this is the commutative law of vector addition. Similarly, if we want to add the three given vectors, so directly we cannot add the three given vectors. So for that purpose, we have to add first any two out of the three given vectors, and then this sum is added to the third vector, and this is nothing but equal to a bar plus b bar plus c bar. So it is immaterial whether first we add the vectors b bar and c bar and then this sum is added to a bar, or first the vectors a bar and b bar are added and to this sum the third vector c bar is added. So result we get remains c, and this is called as the commutative associative law of vector addition. This is the associative law. And this is commutative law. So that is how we can add the two vectors by using the triangle law of vector addition, and this vector addition obeys both the commutative law as well as the associative law. So this is the first method of vector addition, that is the triangle law of vector addition. Then let us see the second method of vector addition, and that is the parallelogram law of vector addition. While using the parallelogram law, while discussing the triangle law of vector addition, what we did is we have arranged the two given vectors in order. That is, the two vectors are arranged one after the other, and the third side which completes the triangle gives the resultant of the addition. While applying the parallelogram law of vector addition, what we need to do is we have to draw the two given vectors to be added which starts from the same point. Suppose we have this point O. So this is the first vector p bar and this is the second vector q bar. We want to perform the addition of these two vectors p bar and q bar. So by using the parallelogram law method, so for that purpose both the vectors start from the same point. Now in order to use this parallelogram law of vector addition, what we can do, how to obtain the sum of these two vectors. So for that purpose we have to complete this parallelogram. To complete the parallelogram, what we need to do is draw a line parallel to the vector p bar from the end point of vector q bar and draw a line parallel to vector q bar from the end point of vector p bar. These two parallel lines intersect each other at this point. So if we draw a directed line segment from the common point of the two vectors to this point of intersection, this gives the resultant vector r bar such that r bar is equal to p bar plus q bar. So here we can express R bar is equal to P bar plus Q bar. So this is how, by using this parallelogram law method, we can perform the addition of the two vectors. This parallelogram law can be stated as, if the two vectors acting at a point are represented in magnitude and direction by the two adjacent sides of a parallelogram. These two vectors represents the adjacent sides of this parallelogram. Then the resultant is represented in magnitude and direction by the diagonal of the parallelogram starting from the common point. So this side or this diagonal of this parallelogram represents the sum of these two vectors P bar and Q bar. So this is the point A, this is B, and this is C. OABC is the parallelogram. Now if we produce OA in the forward direction and draw the projection from the point B, draw the normal from the point B on OA produced, so this intersect it at the point D such that this angle is 90 degree. Then here what we say is that if theta is the angle between P bar and Q bar such that this angle is also equal to theta. This is the vector P bar and this is the vector Q bar. So theta is the angle between P bar and Q bar. Let alpha is the angle subtended by the vector R bar with the vector P bar, and beta is the angle subtended by R bar with the vector Q bar. If it is so, then we can obtain the magnitude of this vector R bar as well as the angles alpha and beta subtended by R bar with the vectors P bar and Q bar in terms of the magnitudes of the vectors P bar, Q bar and the angle theta between them. The magnitude of this resultant vector representing the sum of the two given vectors is expressed as R square is equal to P square plus Q square plus twice P Q cos theta, where P and Q are the magnitudes of the vectors P bar and Q bar, and theta is the angle between the two given vectors P bar and Q bar. Here this R represents the magnitude of this resultant, which represents the sum of the two given vectors P bar and Q bar. Similarly, we can obtain the angle alpha subtended by R bar with P bar. Angle alpha subtended by R bar with P bar given by the expression tan alpha is equal to Q sin theta divided by P plus Q cos theta. this is how we can obtain the angle alpha subtended by r bar with p bar. Similarly, we can obtain beta, the angle subtended by r bar with q bar. The angle beta is given by the expression tan beta is equal to p sin theta divided by q plus p cos theta. So these expressions gives the magnitude of r bar, the angle subtended by r bar with p bar, and this expression gives the angle beta subtended by r bar with q bar. So that is the parallelogram law of vector addition. And finally we have the polygon law of vector addition. So let us see. Polygon law of vector addition. This polygon law is used whenever we want to add large number of vectors. Whenever we want to perform the addition of large number of vectors, we make use of the polygon law of vector addition. Now, whenever we want to use this polygon law of vector addition for performing the addition of two or more vectors, then what we need to do is we have to arrange all the vectors in order. First we have to add all the vectors in order. So let us start from the point O. So this is the point O. From this point O, let us consider the first vector p bar. Draw the first vector p bar. From the end point of vector p bar, let us draw the second vector q bar. From the end point of vector q bar, let us draw the third vector r bar. From the end point of r bar, let us draw the fourth vector s bar. From the end point of s bar, draw the next vector t bar, and so on. And let us consider we want to add all these vectors p bar, q bar, r bar, s bar and t bar. So whenever we want to perform the addition of these vectors, first we need to arrange all the vectors in order. And once all the vectors are arranged in order, then if we complete this parallelogram by drawing the directed line segment starting from the initial point of the first vector to the end point of the last vector, then this side of this polygon represent the sum of all the given vectors. So this is the vector u bar. So we can express u bar as the sum of p bar plus q bar plus r bar plus s bar plus t bar. So the sum of all these vectors results into a single vector u bar. So this is how we can make use of the polygon law of vector addition for performing the addition of number of vectors. This polygon law is nothing but the repeated application of the triangle law of vector addition. How? Let us see. Suppose we draw the starting from the first vector to the end point of second vector like this. So if we consider this triangle, this is the vector p bar, this is the vector q bar. So this side will represent the sum p bar plus q bar. Then this side, this vector plus r bar gives this vector p bar plus q bar plus r bar. Then this side will give us p bar plus q bar plus r bar plus s bar, and then p bar plus q bar plus r bar plus s bar plus t bar is equal to u bar. So we get this resultant vector u bar, which represents the addition of these vectors p bar, q bar, r bar, s bar and t bar. So this polygon law of vector addition is nothing but the repeated application of the triangle law of vector addition. So these are the three different methods by which we can perform the addition of the vectors. So subtraction of the vectors will continue in the next video. Thank you.